Find the domain of the function. So we said something on an earlier problem about we have to make sure that whatever is inside of our logarithm has to be greater than 0. So this is really a question of where is x to the 6th power greater than 0. So we could graph this whole thing if we wanted to and try to find the domain, or we could graph x to the 6th and try to see where that's greater than 0. What I would do is I would say, let's think about this. If you plug in negative numbers into x to the 6th power, like if you plug in -2, it becomes a positive because you're raising it to the 6th power. It becomes positive, who knows what, 2 to the 6th power is positive 64. And then obviously if we plug in a positive number, that would also give us a positive number. The only time I have a problem with this is when I try to plug in 0, because if I plug in 0 and I take 0 to the 6th power, I get 0, and there's no equal to symbol here. So we can't have 0 for a logarithm. Oops, sorry. So that means that our domain would be everything that doesn't include 0. Which is this, from -infinity to 0 and from 0 to positive infinity. Find the matrix product, if possible. Well, let's figure out if it's possible. This is a 2 by 3 matrix, and this is a 3 by 2 matrix. And what matters in matrix multiplication is the middle numbers are the same, and what we're going to end up with is a 2 by 2 matrix. So we start off here by doing the first row by the first column. So we're going to do 1 times 3 plus 3 times -3 plus -3 times 0. That's going to be what goes in our top left spot in our matrix. And then we can move either direction. We can do the first row and the second column, and that's going to give us the top right element. So 1 times 0 plus 3 times 1 plus -3 times 4. And then we would move down in rows. So that's not down. That's the same. Down. And then first column. So that would be 3 times 3 plus 0 times -3 plus 4 times 0. And then we would move this. So 3 times 0 plus 0 times 1 plus 4 times 4. Okay, so we need to work out what each of these is. One thing we can do is get rid of all of these that end up being 0. That's lovely. So what this ends up being is -6, -9, 9, and 16. Solve the system of equations by finding the reduced row echelon form for the augmented matrix. Who are we kidding? You're going to get to use the calculator on this whole test, and it's multiple choice. So I'm going to guess that we would just put this into our calculator and make it do the reduced row echelon form for us. So here's what you do. You do second x to the -1, that is where the matrix menu is. And you go over to edit and you type in this matrix into your calculator. Then you do second quit to get out of there. Then you go back to the matrix menu. And you go to math. And you scroll down to RREF. So you press enter on RREF, you go back to the matrix menu, and then you press, like if it was matrix A that you typed into, then that needs to be next. So on your your calculator screen, you should have RREF, and then whatever matrix you picked. And then you press enter and it tells you like ones and zeros and ones. And then these numbers here on the side should be your answer, which you should get that we have 0, 3, and 0. Well, again, we have our calculator, but this one is really easy to do with Gaussian elimination, which is just normal elimination. If we put these two equations together, we can eliminate the y's and get 2x plus 5z plus 11. And then if we put these two together, if we add them, we get 3x plus 5z equals 14. So then we could multiply this by a -1. So we can cancel out our z's. That gives us x equals 3. You go back and plug in the x to one of our equations that only had x's and z's, like 2x plus 5z. That should have been plus 11, not equals 11, right there. I mean, it should have been equals, not plus. I don't know what I just said. So this is 6 plus 5z equals 11. You'd subtract the 6. 5z equals 5. Divide by 5. Z equals 1. And you take all three and plug them into one of our first equations. So 3 plus y plus 1 equals 9. Means that y plus 4 equals 9, which looks weird. So y equals 5. So 3, 5, 1. Find the indicated matrix product or state that the product is undefined. These are both 3 by 3s, so we can do it. These actually work out pretty cool, because if I do 0, 0, 1 times 6, -5, -5, 0 times 6 is 0, 0 times -5 is 0, so we're really just doing 1 times -5, which is -5. And then our next one that we do, if we do 0, 0, 1, and we do this one, well, that's a 0, that's a 0, then we put 2. And then if we do it with this one, that's a 0, that's a 0, we get -9. With our next row, 0, 1, 0, if we do 6, -5, -5, well, that is 0, that one's not, that one's 0, so that's -5. If we do it with this one, that one's a 0, that one's a 0, so it's 4. Do it with this one, that's a 0, that one's not, that's a 0, so we get -5. And last row, the first one's not 0, the second two are, so that's 6. The first one's not 0, the other two are, so that's 4. On the third one, we have -5. So if you look at this, we basically took this matrix and flipped it, like this column is now in the opposite order, this column is now in the opposite order, and this column is now in the opposite order. Go figure. Find the inverse of A if it has one, or state that the inverse does not exist. So we're going to type this into our calculator, and you type it in just like this. I don't even know why I'm rewriting it. And then once it's in your calculator, you go to the matrix menu and you get matrix A or whatever you plugged it in as, and then you press the x to the -1 button, and so it puts a -1 right there. And so if you press enter, it tells you the inverse of A, which is -3, 10, -3, 2, -4, 1, -1, 1, 0. We learned how to do 2 by 2 matrices by hand, but not 3 by 3, so we have to put that in the calculator. Find the standard form of the equation of the parabola, where we have a focus at 1, -5, and a directrix at y equals -15. So if you look at your stuff on parabolas, then because the directrix is y equals something, we know that we're using the standard form where y is not squared. Okay, so we know we're going to end up filling in for this. If the focus is at 1 comma negative 5, we know that that means that we have h times k plus p. Basically, the directrix being at y equals negative 15 tells us which column to use. So that's how I got this information for the focus. And then for the directrix being y equals negative 15, we know that that is the same thing as y equals k minus p. So we can say, okay, well, I know what h is. H is 1. And then we can say, well, these have to be equal and these have to be equal. So k plus p equals negative 5. K minus p equals negative 15. That's a system of equations. So cancel out your p's. This is 2k equals negative 20. Divide k equals negative 10. And then we can plug that back in to one of these two equations to get p. Negative 10 plus p equals negative 5, so p equals 5. Now we plug all this into that standard form that we said it had to match up with. X minus h is x minus 1, 4 times p times y minus a negative 10. So this is x minus 1 squared plus 20 times y plus 10. Number 26, we have a radio telescope with a parabolic surface. If it is 1 meter deep and 20 meters wide, how far is the focus from the vertex? They aren't telling us the focal width. They never said the words focal width, but we can say, well, there is a point at 10, 1 for this parabola. There's also a point at negative 10, 1 because of the fact that this is 20 wide. And since we know that those are points on our parabola, that's an x and a y that we can plug into our standard form. Speaking of standard form, this is a parabola opening up, so the standard form is x squared equals 4py. We plug in one of our points, so 10 squared equals 4p times 1. So that's 100 equals 4p. So p equals 25. And that's what they wanted in the problem, was how far is the focus from the vertex, which this is the same thing as just what p is.